Have you ever wondered what makes your smartphone so smart, your electric car so efficient, or those wind turbines so powerful? The secret ingredient, the magic dust of modern technology, is a group of elements you might not have heard much about, the rare earth elements. But what exactly are they, and are they really that rare? Let's dig in and find out. First things first, let's clear up a common misconception. The name rare earth is a bit of a misnomer. These elements aren't actually that rare in the Earth's crust. In fact, cerium, one of the most abundant rare earths, is more common than copper. The name originated in the 18th century when they were first discovered in uncommon minerals and were difficult to separate from each other, making them seem rare at the time. So, what are they? The rare earth elements, or REEs, are a set of 17 metallic elements. This group includes the 15 lanthanides on the periodic table, that's the block that usually sits at the bottom, plus scandium and yttrium, which are found in the same ore deposits and have similar chemical properties. Think of them as a big, chemically similar family. They all have unique properties that make them incredibly useful, and often irreplaceable, in a huge range of applications. Let's break down why they're so special. Imagine you have a set of superpowers. One rare earth element, like neodymium, has the superpower of creating incredibly strong magnets when combined with iron and boron. These aren't your average refrigerator magnets. We're talking about magnets so powerful they are essential for the tiny high-performance motors in your phone that make it vibrate, the electric motors in hybrid and electric vehicles, and the massive generators in wind turbines. Without neodymium magnets, our green energy transition and our portable electronics would look very different. Then you have others like erbium, which has the amazing ability to amplify light signals in fiber optic cables. Every time you stream a movie or make a video call, you have erbium to thank for helping that data travel vast distances across oceans and continents without losing strength. Europium and terbium are the artists of the group. They are phosphors that give us the vibrant reds and greens on our TV screens, LED lights, and smartphone displays. They make colors pop with an efficiency that other elements just can't match. Another key player is lanthanum, which is used to make special lenses for cameras and telescopes, reducing distortion and giving us crystal clear images of everything from a family portrait to distant galaxies. Yttrium is a workhorse, used in everything from high-performance spark plugs to cancer treatment drugs, and even as a red phosphor in older CRT televisions. Scandium, when added to aluminum, creates an alloy that is incredibly strong and lightweight, perfect for high-end bicycle frames and aerospace components. The list goes on and on. Each of the 17 elements has its own unique niche, its own special contribution to the world we live in. So, if they're not rare, what's the big deal? The challenge isn't finding them. It's mining and processing them. Rare earth elements are typically not found in concentrated, easy-to-mine deposits like gold or iron. Instead, they are widely dispersed and mixed in with other minerals, often in low concentrations. It's like trying to bake a cake where the sugar is scattered in tiny grains throughout a giant mountain of flour. You have to process a massive amount of ore to get a small amount of usable material. The extraction process itself is the real hurdle. It's a complex, multi-stage chemical process that involves separating these 17 elements from each other. Remember how I said they're a chemically similar family? That similarity makes them incredibly difficult to pull apart. It requires a lot of energy, a lot of water, and a lot of potent chemicals, like strong acids. Historically, this has led to significant environmental concerns, including water and soil contamination, if not managed with extreme care. This environmental cost and the sheer technical difficulty are the main reasons why rare earth production is concentrated in only a few places around the world. For a long time, China has dominated the global supply of rare earths, producing the vast majority of the world's processed elements. This concentration of supply in one country has raised concerns about supply chain vulnerability. If production were to be disrupted for any reason, be it political, economic, or environmental, it could have a ripple effect across countless global industries. From consumer electronics and automotive manufacturing to defense and renewable energy, this is what makes rare earths a matter of strategic and economic importance for many nations. In response to these concerns, there's a growing global effort to diversify the rare earth supply chain. New mining projects are being explored and developed in countries like Australia, the United States, Canada, and parts of Europe. Scientists and engineers are also working hard to find more environmentally friendly and efficient ways to extract and process these elements. Think of new chemical processes that use fewer harmful substances, or even bioleaching, which uses microorganisms to help extract the metals from the ore. Another huge area of focus is recycling. Think about all the old phones, laptops, and other electronics we throw away. They are a treasure trove of rare earth elements. Developing cost-effective ways to recover these elements from e-waste is a major goal. It's like creating an urban mine. Recycling not only reduces our reliance on new mining, but also helps tackle the growing problem of electronic waste, turning a problem into a valuable resource. It's a win-win. So, the next time you pick up your phone, get in an electric car, or see a wind turbine spinning on the horizon, Take a moment to appreciate the hidden elements that make it all possible. The rare earth elements are the unsung heroes of the 21st century. They are not just lumps of metal, they are the enablers of innovation, the building blocks of our high-tech society, and a critical component in our journey towards a more sustainable future. Their story is a fascinating mix of chemistry, geology, economics, and environmental science. And it's a story that is still unfolding. Thank you so much for joining me on this deep dive into the world of rare earth elements. I hope you found it as fascinating as I do. If you enjoyed this video and want to learn more about the science and technology that shape our world, please hit that like button and consider subscribing to the channel. It really helps us out. Got any questions or ideas for another topic? Drop them in the comments below. Thanks for watching, and I'll see you in the next video.